Welcome, 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 and good evening, everyone. I'll wait for a moment until we have more people on the line. Thanks for watching. Let's sort some components out. Okay, so today we have a PCB assembly, and I am going to assemble a small PCB, very small, with a dozen components only. I'll be fast, but although it's small, it's always good to show. So I have a panel. You can see photos of this panel and single PCB on my previous post just minutes ago. I can show you. It's a panel with 20 PCBs. See if we can focus. See, 5 by 4. These panels like this are the ones that go into the machine in a factory, and then there's a head with components that goes and put in, pick and place on each part and on each place. So this is ready to be factory produced, factory assembled, but as I want to test the design, okay, I know it works, it's a proven design, but I respinned the PCB with a different layout. It was larger, it had more components, so I took stuff out, I changed a bit, but I know that the design works. So I'm gonna assemble one. I'm going to assemble one just now for you to see, and while I'm assembling it, I'll talk you through it. Okay, so it's a simple circuit. It's a LiPo, a lithium polymer battery charger, and the power input is from USB or an external 5-volt supply. It has a USB connector, it has a connector for the battery, and on the same board there is a power supply. It's a very small power supply. It's a switch mode power supply. It's a buck power supply, so it's a step down, so it will take the between 4.2 and 3.6, 3.5 volts of the battery and will convert it to 3.3 volts. It's very low power. The quiescent current of the switch mode power supply chip is around, if I'm not mistaken, 5 or 6 microamp, and the reason for that is because this board, every PCB will be attached to a bigger system that is going to be power supplied, battery supplied, and the total sleeping current of the system has to be really low, ideally below 10 microamps, and so this board is competing on that power. But since the system will be picked up and fast charged every 2 or 3 months, we can live with that, with those microamps. So let's start with the USB charger. The USB charger has mainly the USB connector. It has a fuse. It's a polyfuse, so it's a resettable fuse. It has the charger controller chip, and just few resistors and capacitors for filtering and polarizing and biasing, and also a LED to tell us that will tell us when the USB charging or the battery charging is over. So what we'll start with that before we go into the switch mode power supply. So two modules. First, the USB charger. Second, the power supply. Okay, I will start with the USB charger. I will not solder the USB connector first because it's the biggest thing on the board, and I will leave that for later. I will solder, yes, resistors and capacitors that are very small. The size is, for those of you that understand the sizes in electronics, I've chosen for this project 0402 components, very small. Let me see if I can show you the size. That's around 1.6 millimeter by 1 millimeter, if I'm not mistaken. Very, very small. I'll put the tip of the tweezer. Very, very small. I have a crystal, a watch crystal here. I'll put besides it. See, even the pins of the crystal are almost the same size of the component. So I'll start with the passives, resistors and capacitors. So we have here a 4.7 microfarad capacitor, 6.3 volts. And this is a capacitor that will be used to filter the power that's coming from the USB. Okay, so we need to filter that power, because the USB voltage supply, it's always very, very noisy, and by using a capacitor at the input of our circuit, we can improve the power going into the charger chip, so it charges better. And also the power peaks needed for the charger chip are not felt by the USB supply in a bigger magnitude, so it will filter all those peaks. So let's turn on the soldering iron. It helps. I'll pick up the capacitor and I'll try to show you. Let me see if I can find a piece of paper here. A piece of paper, so I can show you the size of the capacitor. It's really small. I don't know if you can see it. Maybe like that. Very small. Right. So you have to be careful with these components. This is not, well, although it's small, it's you can still solder and work with them by hand without the need of a machine. Of course, if you have a microscope, it will help immensely, because you can see really close what you are doing. But you know, if you don't have, that's not an issue, that's not a problem. And these are the ones that you can still manage to work by hand. If you go lower, if you go half the size, you will need, or it will help tremendously if you use a microscope. So let's apply a bit of solder to the pads of the component we're going to solder, so it will help. Yeah. Right. Right. Pads are very small, so just a bit of solder. Not much. Don't put too much. It's better to put less than too much, because it's easier to solder this way with less solder. I'm putting on all the other components. The tip of the iron is very thin. You probably can't see it. It's very thin, so I need to apply more. I need to apply heat for a longer time for the heat distribution happen, because this is very small. Okay, I think we have soldered in all the components. Maybe the fuse. That's it. All right, the LED. Let's solder the capacitor now. All right, capacitor in its place. All right, half of the capacitor is soldered. Now we go. See if I can. I know what is the camera here. It doesn't help much, but you know, I will try. I will explain as I'm soldering. So one part of the capacitor is soldered. Let's solder the other bit. Okay. Let's put a bit of flux and redo the soldering. Flux helps a lot. Okay, we have the capacitor soldered. Let's move on. First capacitor is soldered. Now we have a few resistors and we need 2.2K. That's later. 2.2K. Same size. 0402, very small. Let's take one. Yeah. You can see how many? 200. 200 capacitors. Sorry, the resistors in this small tape. 200. See the size of it? It's amazing. Alright, let's take one. Okay. To be careful not to sneeze, because if you sneeze, it disappears. Okay, so 2.2K, and that's going to 2.2K, and that is resistor 1, and resistor 1 is over there. Okay, let's do it. Okay, let's start with, again, by putting it down on one path. Okay, that's it. Let's put a bit of flux, just a little bit, not too much. And let's apply solder again on the other side. That's it. If you guys want to check, you should check your work. Get a magnifier. This is at 3 times. For me it's enough, but you know, you decide what's good for you. Just checking if the component is well soldered. This is small, you need something to help you out. Yeah. Okay, so that resistor is soldered. Next one is R2, and that's the polarizing resistor for the LED. So that's 1K, 1 kilo ohm. That's it. 1 kilo ohm again. How many do we have? 200. And again, as you can see, 200 resistors. This bit of tape. And let's take one. Okay. Be careful again. Don't breathe too close, because you can inhale the resistors. That doesn't help. Okay, so same thing. Grab the resistor, grab the component. There is one pad has already solder applied, so heat the solder. drop the component, and there you go. Let's put a bit of flux again, just a wee bit. Okay. Can't see properly. Cannot see. Small. I think so. It needs a bit of heat on one of the sides to improve the solder. Okay. Yeah. You know, it's sometimes with these small components, when you apply heat to one of the pads, because the component is so small, there is heat transfer throughout the component that goes to the other pad, and they both melt, and the component aligns itself on the pads. So in this case, before I applied the flux and then the iron, the component was misaligned. When I applied heat on the other side, it melted everything and aligned itself. So it's better than it was. So this is very common in surface mount assembly. If you look at the machines, if there's a camera inside the machine, when the PCBs go through the oven, you will see the PCBs. You will see the components aligning themselves with the heat. That's something that is expected, and it's very common, and it helps to put the components in place too. Some of the components are misaligned, are obliquous to the pad. It will be put in place. Okay, so now we need to put the fuse, the output capacitor, and the LED. Let's start with the fuse or polyfuse. Okay, it's a polyfuse. A polyfuse, it's a thermal fuse that resets itself when you take the excess current flowing through it, or the power through it. It just resets itself and returns to the normal condition. It's very helpful in preventing overcurrent situations with some circuits that don't like overcurrent, and that's the case of USB. It's because I only want to draw 500 milliamps from the USB supply. That's on purpose. I'm putting a polyfuse of 500 milliamp, so I know that the nominal current that can go through the fuse is 500 milliamp. Above that, it will start to increase the resistance, and if the current is too much, the resistance go almost to infinity, and it cuts everything. So let's solder the fuse. The fuse is a bit bigger, so we need a bit more heat. I'm going to rotate the iron so we're gonna have more heat applied. That's it. One of the sides. Let's put heat on the other side. Okay. Alright. Looks like it is. Yeah. Good. That's good. Right. So the fuse is in place. Now we need find out the capacitor, the LED, and the USB connector. Let's start with them. So we have here the charger chip. That's always the last one for me. That's the LED, and the big capacitors. That's here. Okay, so the output capacitor, the one that it's in parallel with the battery, It's 10 microfarad. It's a bit bigger now. Now you can see this one. You can see. Let me take it. It's a 10 microfarad. The package is a 1206, so it's a 4 point something millimeters by 2.2. So this one you can see it's bigger. Yeah, and it's 25 volt one. I don't need a 25 volt one. That was on purpose because this capacitor has special characteristics that I wanted. So by increasing the voltage, you increase the size. That's something very common with capacitors. So by increasing the size, the package of course goes. So it's C2 and C2. Okay. Let's see if I'm not mistaken. Yeah, C3. This is not the best iron tip for this capacitor because it has a lot bigger mass that will dissipate a lot of thermal, but I use the other side of the iron. We heat up everything and there we go, soldered in one place. So let's do the other side again. Okay, let's apply a bit of solder to the other side. So okay, so like it looks like this is you can see, you can probably see the size is bigger, so you can see these. I know that the image is not focused, but I will take a very close photo at the end, a macro, and put it on the profile. So last before the charging chip is the LED. The LED needs to be, the package needs to be open. The LEDs normally come, these are special electronic components that need to be in protective environment. So these packages come with humidity controlled silica gel and special an indicator of the humidity that the components have already suffered. I'll show you. Because after you open the package, you need to use the components straight away, or if you don't use them straight away, you need to close it again on a special controlled environment. So silica gel, there's a small card that comes with the components that gives you the percentage of humidity that the component has taken. So when these colors begin to change to pink, you know that you have reached the level that you need to pre-process the components prior to soldering, and the pre-processing is called the baking. And the baking is normally done by putting the components in the oven at around 100 degrees, 150, it depends on the component. Doesn't say here on the package. Let's see. Yeah, it says you need to follow this procedure, IPC, GDEC, etc., etc., and that says exactly how the temperature, and normally it's for 24 hours. You need to put it in the oven at that temperature for 24 hours, so the component releases all the humidity, it's completely dried, and then you can solder. If you don't do that, you risk that when you put the components on the PCB and you take them to the oven at 260 degrees, the humidity will start to evaporate and boil. The humidity starts to boil, and you can have, components can break, and sometimes I've seen not explosions, but it's not break, it's not explode, but it's just they go through the oven at high temperature and poof, they do like this. So we need to be very careful. Since we're not putting the component in the oven, everything is going to be soldered by hand. There is not that issue. But if you ever do a small run and you have components that need to be baked, always bake the components. Believe me. Always bake the components is really, really important. Even if you don't have the time, believe me, it's better to lose 24 hours than to lose the whole production. Believe me, I've been there and it's not pretty. So let's take one lead off. Okay, one lead is out. And how many leads? 150. 150 leads in this tape. Let's see. You can see it's not big, that's 150 leads. So let's tape all this together again. Let's put the silica gel. The packet is open, but it's better to have the silica gel there than not to have it. Okay, so now I need to find out what's the anode and the cathode. There's a green arrow here that indicates the anode and the cathode, but of course I will confirm with a multimeter for you to see. So small again. My tweezers are a bit magnetized, so it doesn't help. Okay, so let's get just confirm that this one is the anode, and that's the. I don't know if you can see the light. If the camera shows the light, I'm not sure. Maybe. Okay. So I need to solder like this. Let's pick it up. Solder one side fast because I don't like heat. Let's put a bit of flux to help. Solder the other side, the other part. Okay. That's good. Looks good. Alright. And now we need to solder the last component before the connector is the charger chip. Okay. Charger chip. Let's take one. The charger chip, it's a microchip one. It's a very good chip. I've been using these charge controllers for a long time. There are others on the market, but I've used others. They all work. I've kept using this one because the costs are the same and never failed me. So unless it's a very big production that other manufacturer will do you a better price, but in this case we're talking about only 100 PCBs to be done, so it's a no-brainer. Let's do it again with the same. Okay. Okay, so the package for this I'll show you. It's so small that it runs away. Oy, oy, oy. It's called a SOT 23 with 5 pins. So it's a SOT 23, 5 pins, sometimes known as SOT 25 too. Alright, let's solder one pin. Okay, one pin is done. When you pre-solder one of the pins of the components, so it's a big help, because you position the component, you apply heat, that's it, the component is fixed. And you can mess with your PCB and it doesn't come out. So now you go and solder the other pins. There is no need to put more flux, because there is plenty of flux residue on the PCB. The ground pin is always the one that takes a bit more heat, because there's a more heat dissipation, because there's on the other side of the PCB it's a copper plane, so the heat dissipates here, so the iron needs to be strong, and the iron is good, but the tip is so thin that if you don't apply enough heat, even the best soldering iron will not help you. Let's put a bit of flux. Okay. See. Yeah. Alright, so last but not least, it's the USB connector. And the USB connector, B packet. We have 110. I always buy a bit more, because I was not sure if I was going to manufacture this or do it by hand. So if you're gonna manufacture, always add at least 10% of your components, because the machine needs to be set up, and that setup sometimes takes some components just for testing. So USB connector is a mini USB. A mini USB. It's strong. It's a strong connector. I prefer the mini USBs to the micro USBs, because they're a bit bigger and they are very sturdy. So if you do the paths correctly, they can't be seen. There are, let's see, maybe see there are 2 plastic pins there, and those plastic pins go into the PCB and help to fix and keep in place the component, so it doesn't go. Yeah. So I had 1 pin soldered. Let's do it. That's it. Okay, so I'll start with the ground again, because the ground will take more heat. The tip of the iron is so small. Yeah, okay, we've done it. So let's solder the other pins. You probably didn't need to solder the other pins, since we are only using the power pins. But to keep the mechanical integrity of the component and the PCB, just solder all the pins, and the mechanical pads, the mechanical pins are here for. Let's see if you can. These pins here on the side, right? There are a couple of pins to give mechanical integrity after you solder it. component stays locked, it doesn't move. So apply a bit of heat. That's it. Okay, it looks good. Okay. Right, so everything looks in order for the USB charger part module. So I've soldered the passive components, and that's the resistors and capacitors, the fuse, the LED, the charger chip, and the connector. So the LED goes off when the charging is over. So I'm gonna test the circuit, and I know that the LED will come on and will go off very fast because there is no battery on the circuit. I will put a battery here for testing. I'll just put a couple of pins, but before I show you these, let's see if you can see that when I apply, let's see, when I apply power, you'll see a LED blink on and off. Okay, but when I apply power to the USB, the charging starts, but since it reaches the plateau of the voltage, and that's 4.2, the LED goes off because it thinks that the charge is over, but there's no battery. Let's do it again. Okay, see, it goes on and off. Yeah, sometimes it blinks because it tries, the voltage goes a bit down and it tries to, doesn't happen always. Let's see if we have 4.2 volts at the output of the battery. I'm sure we will, because it's how it works. Okay, so ground. The ground, this is the ground. Okay, and I'll show you. Measuring. I am measuring the voltage at the terminals of the battery. There's no battery applied. And you apply when you put the battery here, it would slowly increase the voltage because it's charging it, and when it gets to 4.2, 4.5, there's a small error, it will stop. So you can see the LED is off and the output voltage is 4.2. So okay, it's a mirror image. Okay, I'll tell you, it's 4.28. Sorry about that. I'm using the front camera. Maybe if I switch to the backwards camera. Let's see. Just for a bit. Let's see if we can change the cameras. Okay, there we go. Battery terminals. There we go. 4.2, 4.28, 4.3. Okay. So now I have. Let's change again. I have a few pins I can solder just for a test. First, of course, take the USB connector. I need a couple of pins, and I have a few batteries lying around somewhere here. when you know these batteries from cameras is $1, and they are very handy. Just take the plastic off if you don't want. Or you can solder to the terminal. You see those 3 terminals? One is the sides are the ones you use. The middle is a thermistor for temperature check, but you use the sides because you have here I don't know if you can see minus and plus and minus. You solder a couple of wires and you can use the battery for whatever you want. So that's a lithium ion. You can charge with this with the same chip. So that's the thing I'm gonna do. But I have another one here. I have another battery here. That's the 18650. Let me change the camera so you can see what I'm saying. Let's see if it focuses. Yeah, it's the 18650, 3.5 amp. These are very good batteries. You can get them on the internet, eBay. Please check who sells them, because some are fake and some are very good. So this is actually a very good one. I'm not sure if this is a Panasonic or a Sony battery, but this is good. So I have a connector here, a socket for the battery. This one was almost empty the other day. I'm not sure if it's going to charge. Yeah, not sure if it's going to charge since it's so empty around. But 0 baht. So let's solder a couple of pins so we can test the charging for you guys to see, and then we can go to the power supply. You don't need very thick wires, just because there's no currents here. Half an amp is nothing. So you know, when you are soldering through hole components and you cut the pins, if you save the pins, you can use them for other purposes. And these pins are very good because instead of soldering headers and connectors on the PCBs, you can solder these pins and use them for testing purposes. So very good. Alright, so that's battery output. Let's solder one here and another here, and we have to watch out, don't burn yourself. Okay, one is down. That's it. Yeah. Now I'm gonna need some alligator clips. Let's get some alligator. So now I'm going to connect the positive. I have some crystals, 32 kilowatt crystals lying around, so if you sneeze, they go away. Alligators, positive, negative, and negative. Let's put the USB. Okay, so see, now the LED is on. If I disconnect the battery, the chip, the charger chip, will think that the battery is complete, the charging is complete, so it will turn off the LED. See, if I put the battery again, it detects that a new battery is there and it needs to charge it. Right. I'm sure the voltage of the battery is really low because I was really severe the other day with this battery. So yeah, I'll show you the voltage meter with the other camera. If I can change the camera, yeah. Let's see. You see the voltage increasing slowly because it's a powerful battery. So when it gets to 4.2 x, it will stop. It will take a few hours because the battery is really discharged, and we have 3.4 amp, so it will take a while. I may leave it here overnight. So okay, so we know that it is charging. Let's see how much current it's charging with. So I'm going to use the same multimeter. I'll change just going to change from volts to milliamps. Change the plug and put the current meter in series with the battery. So we check how many amps we are charging with. Okay, so I need more crocodiles. Maybe not. Maybe not. I'll use the hand just to show you that how much is the current. I put one crocodile on one. Okay, see? The current oscillates bit. It's half an amp. Goes up and down a bit. It's stable. This current can be controlled with one of the resistors on the board, and the resistor I've soldered fixes the charging current at half an amp, 500 milliamps. Okay, let's change cameras again. We'll continue charging later, but for now let's proceed with the assembly. Let's now assemble the DC to DC chip. Let me take the battery off the connector because it's safer. Let's put these away. Okay, so now we need the components for the charging. Let's take the USB connector out. Put the pins. Okay, so there are many, so we need just 6 components too. And again, I'm going to need the 10 microfarad capacitors here. See this bag? It is small, and it's 500 capacitors. 500. If you want to know which capacitor it is, okay, it's mirrored. It's a 10 microfarad, 25 volt X7R. The brand is Tayo Yuden. Very good capacitors. If you want a reference, I can give you later. Okay. We need this capacitor. The other components I can put it away. We don't need it anymore. So 100 nanofarad, 1 megaohm resistor. That's the inductor for the switch mode power supply, and that's the chip power supply, and that's it. Simple. Okay, so let's start again with the smallest passives. Let's start with the resistors. We have couple of resistors, yes, two resistors to solder. Let's start with this one. The resistors are here. They are at the output of the battery. It's two resistors of 1 ohm, and they make a voltage divider, so I can measure the battery voltage in the center. I will have half the battery voltage. This resistor is 1%, and I know I will have a load on the battery that is continuous, but it's a very, very, very low current. If I don't need it, I just desolder the resistors again with a bit of hot air, and I can save that power. But you know, if you divide 4 volts by 2 million, you'll see how much current is going to be wasted. Almost nothing. And it's enough to measure the voltage. I measure slowly, measure once a few seconds, so there is enough time for the internal capacitance of the analog to digital converter to charge and give you a proper reading. Okay, so two resistors. I'm going to solder these two resistors, R3 and R4. Where are they? Okay, here they are. Again, very small, very, very small. Have to be careful not to lose them. Solder one pad. I will solder the other one because they are close together. Okay, and I will not solder the other pads yet, because in parallel with the bottom resistor I have a 100 nanofarad capacitor that helps me filter the voltage. So I'll put, if anyone wants a schematic, I can give you the schematic for this. It's a simple circuit, so just ask me a private message, I can send it to you, no problem whatsoever. Okay, so since that capacitor is in parallel with that resistor, I'll solder the capacitor first, and then I'll solder all the pins. Okay, now apply just a bit of flux. And let's solder the other pads. Okay. Let's see with the magnifier. This is so small. I think the capacitor needs a bit more solder, just in case. Yeah, just a bit, not much. The thinner your solder wire, the better. Okay, that's it. No more. Job done there. Okay, so the smaller components are done. Next, I will solder two 10 microfarad capacitors. Okay, two 10 microfarad capacitors. And I need 2, 1, 2. Okay. One at the output of the battery, and another one at the output of the 3.3 volts. It's for good stabilization of the voltage. The main board has very good, decent capacitive filtering and other types of filtering, but it's always good to have a capacitor like this in this board because it will help filter the noise and the peaks. It will smooth everything. If you can, don't spare on the capacitors and in the filtering because it will help you. Okay, so bit of solder. There's a lot of capacitor is big, so the thermal mass is higher, so you can apply a bit more heat this time. And there we go. Okay, let's solder the inductor for the switch mode power supply. And the inductor for switch mode power supply, that's it. This one is a Coilcraft, if I'm not, yeah, it's a Coilcraft. Coilcraft inductors are very good, so. I have one of the pads soldered, so let's apply heat. There we go. Let's go to the other side and apply heat and solder. That's it. Job done. Let's have a look. Let's see. Yeah. Okay, so last 3.3 volt chip. Again, 110 chips. Very small tape. It's the same package as the battery charger. It's SOT23 with 5 pins. So there's no power involved here. We're talking about 600 milliamp. Yeah, 600 milliamp max. So the sizes are small, and 600 milliamp is more than enough. More than enough for what we need to do. All right, so we need a bit of space here because that's the last component. I normally start with the chips. If I have a big chip with lots of pins, and that's the hardest component to solder, you guys should start with those, because if the soldering goes bad and the PCB gets wrecked, you don't lose all your work of soldering all the components, and then at the last one you lost a few hours of work and you have to scrap it. No, start with the hardest one. In this case, these components are easy to solder. Let's put a bit of flux to help. Okay. To the other side. Let's clean the tip. Sometimes it needs to be cleaned. Okay. There we go. Let me have a look. Yeah, maybe a bit more solder. No, that's okay. All right, looks good. Again, let's solder a couple of pins just for testing purposes. Can connect USB here. you see that the LED now is flashing. There is no battery attached, but the LED now is flashing. And why? Because the switch mode power supply is asking for some current to regulate the 3.3 volts, and so the charging chip thinks that it has a load, that it's the battery, so that's why it goes to charge, no charge, charge, no charge, to keep the 4.2. So the 4.2 are going to be converted to 3.3. So all right, oh, sorry, let's connect the changed cameras. I'm measuring voltage at the output, and there we go, 3.3. There is no load. I'm sure when you apply a load, that will level to 3.3 or closest to 3.3. Even 3.25 is good. Okay. All right, so that's it. And this voltage here, it's half of the battery. The battery, I'll show you, there's no battery connected, but the regulator chip is regulating it to 4.1. The voltage divider that gives me half of the battery voltage gives me 2.2. Close enough. There's a bit of error, but that's no problem at all, because I just need a rough indication of how much the battery is, and there is no battery connected. So let's connect the battery now. Let me change the cameras again. Okay, you can probably see the LED flashing. Yeah, let's connect the battery. Let's connect the battery. Let's simulate the battery charging, but it's not simulating actually, because the battery will be here in the circuit, and it's going to be charged at 0.5 amp. Battery, the LED should go continuously on. Will stop flashing. It's continuous. I'll show you the battery voltage now. Should be increasing. Okay. So battery voltage is increasing. Let's see if I can get millivolts. Okay. No. Slowly increasing. See if we go 3.3. That's the battery voltage. 3.3. Let's measure the voltage of the switch mode power supply. What's our output? 3.29. the voltages look the same because the battery was low in charging. Let's measure half the voltage of the, that's it, 1.8. There's a bit of error there, but that's not a problem. Battery voltage 3.33 now. It's increasing. I will connect another multimeter here. First, let me solder some pins that will help to attach the leads of the multimeter, so I can show you. So I can show you both voltages, battery and the DC to DC. Okay, couple of pins. Turn off the power to the circuit, take off the USB connector, disconnect the battery, You don't want to do live solderings with live power, so be careful. Okay. Okay, job done. Alright, so I need more alligators, so I can connect everything. So I'm going to connect one multimeter to the battery, one multimeter to the battery, plus and minus, okay, and the other multimeter will be connected so I need more alligators. Right, so the other multimeter will connect to the output of the power supply, the 3.3 volt. Let me show you both both multimeters. What's happening is very interesting. Let's see. So the right multimeter on the right the multimeter on the right, it's the battery voltage, and the multimeter on the left, it's the DC to DC, it's the switch mode power supply. What is happening, it's very interesting, because for the switch mode power supply to regulate to 3.3, it needs to have between starting 3.4, 3.5 volts from the battery. As you can see, the battery is only 3.1, so the switch mode power supply, it's failing. It gives you 2.9 because it can't regulate. But if we apply the USB charger, let's put the connector, you will see the battery voltage will increase. So the battery voltage started, right? It's 3.3 and going up. And as you can see from the left, the switch mode power supply is stabilizing, and 3.3 goes a bit up. So let's it needs to stay here for a while because the battery will take a few hours to charge. But when it gets to 4 volt, 4.1, the charging current starts to decrease drastically, and until it gets to 4.2, it takes sometimes more time than to get to 4.1. It's how it goes. It starts with a fast charge and then decreases the current. Okay, let's connect this here. Let's take the battery out. Yeah, I can show you this. Yeah, let me show you this. Imagine that I take the battery out of the circuit. Okay, I'm gonna take the battery out of the circuit. See, the charge chip regulates the output to 4.1 because thinks that the battery is completely charged, so it keeps the voltage at 4.1. It tries to inject current, but there's no current to inject, so regulates the voltage at 4.1. 4.1 between 4.1 4.2. The DC to DC converter, there you go. 3.3 volts, 3.37. That's a very good error actually. I'm just curious, I don't have a load here that I can use. Maybe an LED. No, I'll get. Yes, I do have. I have this. Just take the soldering iron. So that's ground. Kids, don't do this at home, okay? All these leads. That the voltage goes down because there is no power from the charging chip, but then it stabilizes. I'm putting. Let me show you what I'm powering the circuit with a radio. Just a prototype what I'm building. Let's see. Okay. I think you've seen pictures of this. This is a remote trigger with a radio. That's a radio, and that's a remote trigger for pyrotechnics. Just a test. And this takes 3.3. This takes 3.3 volts, so I can power the circuit with it. I don't know if you can see the LED flashing. You see the LED flashing? Yeah. If I connect the circuit to the output, the LED goes fixed because the charging chip thinks that it's charging the battery, but in fact it's powering the switch mode power supply. Alright, let's connect the battery. I'll connect the battery to the output and the LED will go continuously on. There we go. Okay, let me change the cameras again. The battery needs to go further for this to be a better perception, but on the right it's the battery voltage and on the left it's DC to DC. Because the battery voltage is so close to the output of the DC to DC that we want, the output of the switch mode power supply is changing a bit. So let's put a load on it. Let's put the radio. See, it drops down a bit, regulates 3.3. I take load off. That's the load off. Load on. Wait. It needs the battery voltage to be higher. So when it gets to 3.5, 3.6, the regulation will be good. Okay, so that's it. Let's change cameras again. Okay, so let's disconnect the battery, disconnect the USB, disconnect all the dangers. Alright, so I've showed you the assembly of a lithium polymer battery charger with a USB, and on the same PCB. I think I'll change the camera. The backwards camera is much better. So you have the USB connector, you have the lithium polymer battery charging chip, and on the same PCB you have a switch mode power supply that regulates the battery voltage to an output of 3.3 volt. And that's it. I have a few of those. As you can see, I will assemble this panel. Not all today, of course, but still have a few components to go. Thank you very much. If you have any questions, if you need any more information, just send me a note. Thank you very much.